Can everyone see that? Give me some feedback.
Yeah,
Yeah, it
Okay,
works
this will
okay.
do. This will do.
Yeah.
Okay.
Okay,
Right.
so
Hello.
great. So our next speaker is Ayers from University of Cambridge, and he will tell us about the magic that we got with
Magic.
Widgets in 2020 as well.
Yeah. Right. Hello. Yes. So I'm Edward Ayers, and today I'm going to talk about lean widgets. And so yeah, at the moment I'm just finishing off a PhD at the University of Cambridge, and then after that I'm going to start working on verification of autonomous vehicles at 5AI, which is this autonomous vehicle company in the UK, and they're looking for interns as well. So yeah, check them out. Okay, right. So what I'm just gonna talk about why I made these things, what are they, how it works a bit, and then the most of it I'm going to try and do as a demo, which might go disastrously wrong, but I'm going to give it a go. Okay, so the basic problem that I want to talk about is about how do you make interactive theorem proving interactive. So if you look at this flow chart, the idea is there are two gray spheres. One of them's a human and the other one's a computer. And the computer's really good at checking logical things, and the human's really good at trying to find things out. And so there's this kind of cycle of information. So the interactive theorem prover gives you a goal state. So e.g. you might have, X and Y, and you want to prove this thing about X and Y. Then a human will look at the output window and go, oh yeah, that simp can do that. Type simp into the editor. And then eventually Lean will get back to you and say whether you've achieved it or not. And so the point of this is what I'm saying. There's an interactive component to it. It's quite different to computer programming to some extent, where you'll write your program and then check if it works. It's very much in automated theorem proving and interactive theorem proving. It's very much a dialogue with the software. So I'm interested in.
Ed, I'm sorry to interrupt. Your Zoom window or your videos are covering part of your slides. Maybe you could minimize that or move them over. We see you twice.
Dear me.
That works.
Okay.
Thank you.
Sorry about that. Yeah.
No.
Yeah. So that's that's kind of like the setting. So I'm interested in the goal state bit. And so there's like a very long history of doing this. So I think the first kind of mainstream one that got a lot of traction was this thing called Proof General by David Aspinall. So here you can see we have an editor, and you also have this proof state down here at the bottom. Sorry, hang on, I don't know why that's there. Yeah, which says, which kind of gives you the proof state, and it looks very, very similar to the info view in Lean, or like basically any of these modern provers look like this. And then more recently, we also have things like Isabelle has like JEdit, and it has a full user interface surrounding the editor. But it's always about you type things into an editor, and then you get a wall of Unicode back saying, okay, you should try doing this, or your goal state is this. And so the question is, how can we make it more interactive? How can we add more components to things? So how interactivity works in Lean, and basically all of these provers, is that there's this server protocol between your editor, which in this case I've drawn as VSCode, and your prover, which in this case is Lean. And then you give it a load of protocols for things like, how do I go to a definition if you give me a symbol? What are some ideas for like how to fix this bit of code? If I type like add com underscore, like what are some possible lemmas that I could complete that with? Type information and the info view, things like that. So the idea is there's like this API that's quite big that you could use to add all these rich interactive features to an editor. But the thing is that one of these is called the language server protocol, which is used by VS Code. So Lean doesn't use that, but it's written for programming languages, so it doesn't really have a lot of stuff to do with the info view involved. That's quite a prover specific feature. So I'm going to look at that here. And so what I noticed in Lean is that there were lots of features that people wanted from their info view. So people wanted to be able to filter goals. There are some little aesthetic things. So it used to say, when you completed a proof, it used to say no goals. And people wanted it to say goals accomplished to make it a bit more positive. You don't get, at least in Lean, you didn't get any type information for the various symbols that were viewed in the info view. And then similarly, people wanted to add like try this thing. So it might say try this and then give a name of a tactic. And then you click on it and then it would insert that tactic into the editor and you could keep going. It was pretty fun. But the idea is that they all have to be like added into the API. Every time you want to make a new way of interacting with the system, you need to like coordinate, you need to add to the server protocol and start adding in, you need to start changing JavaScript code, C++ code sometimes, and Lean code. And it means that the turnaround time for coming up with new ways of interacting with a prover is quite long. But interestingly, Lean uses VSCode. It also uses emacs. Sorry, emacs. I don't have a solution for emacs, but the Lean info view is effectively a full-fledged web browser, and Lean is a full-fledged programming language. So couldn't we just write a full-blown UI framework in Lean, and then we don't need to have this expanding API of things that we want to be able to show in the info view. We can have arbitrary UI in there. So that's what Widgets achieves. So here we can see, for example, is a custom goals accomplished message. So it's written in Lean. So we have the name, and then it returns this thing, HTML alpha. I'll come on to what the alpha means in a bit. But so you can see here, so we have this H, which says make a div. It has the class name F5, which is just some styling to make it look nice, and then make it say the text goals accomplished. And then so you can edit this, and then using Lean widgets, you'll now see that in the tactic state. Okay, and then so the main use of this is that it means that you can have fully interactive info views. So I'll show a live demo of this in a sec. But so here the idea is we click somewhere in our editor, and then it brings up our goal state here, which you should be familiar with. And then you might say, oh, I wonder what that co is doing. I wonder what that weird up arrow thing's doing. And so but now you can click on it, and then it will give you a full breakdown of all the implicit arguments involved. And then it'll also do that recursively. So you can have a look at, click on terms within this pop-up as well, and see recursive information about types and implicit arguments and so on. And the cool thing is that because VS Code doesn't know about any of this tooltip stuff, it's all written in Lean, and so there's I think it was Patrick wanted it's saying my internet connection's unstable, so I'm just trusting someone will shout if stuff stops working. Okay, so we have this definition.
A moment ago, a moment ago, it was stopping for me.
Oh, okay.
Shall I keep going? Glitch a moment ago. It's fine now.
Okay. Well, anyway, I was just saying that there's this go to definition button, which I think Patrick wanted.
Yes.
But the idea is now you don't. So before that would be a huge operation where you have to try and regex the plain text goal state, and then try and figure out, kind of reverse engineer the string to figure out what Lean token it was based on, and then use that to go to definition. But now you can actually implement the go to definition button completely in Lean without touching any JavaScript or C++. So that's what this code does, for instance. So this was just added into Mathlib, and now you have a go to definition button without having to recompile or call Lean or anything. So that's like the dream of widgets, is that you can just immediately have new features without having to use lots of different languages. And so this design is inspired quite a lot by the Isabelle Isar system. Sorry, Proof IDE PIDA system, where you can write in Scala within the Isabelle framework, and it will give you the ability to make UI. So this is a bit different because it's all done in Lean instead, because we can use the fact that Lean is a full meta-programming language. Okay, and then another cool thing is that people have started building stuff with it. So here we can see a Sudoku solver built by Marcus Himmel. So on the left, you can see the gnarly tactics that are being used to solve the Sudoku. And then on the right, you get a visual representation of it, including things like, I guess these are like possible, some kind of constraint satisfaction thing going on there. And then similarly, we have this Rubik's Cube by Kendall Frey, where he's represented each Rubik's Cube state as this cube net, which is pretty cool. And then also, Robert Lewis and Binchao Wu have built this system, this Mathematica Bridge, which you might talk about later, I don't know. But the idea is this uses widgets to show images of plots that are generated by Mathematica. So the idea is it could act as a way of bridging with other tools as well. Okay, yeah, I think it's time for a demo. So pray to the demo gods. Can you see this?
Yep.
Yes.
Yes.
Oh, I heard something. Okay, I'll assume you can see it then.
Yes, we can.
Excellent. So here's just a random lemma from MathLib, and so you can see here how as I move around this tactic, the info view is changing. It's fairly fast, and now if I hover over it, I get these highlights of the strings. So it's kind of semantically aware of how these pretty printed strings are generated. And then so every time I hover over a different part of the expression, it's doing a full round trip to Lean to figure out where the highlights should go. So that means that you get completely accurate highlighting for which sub-expressions you're currently hovering over. And then now I can click on, I can click on this expression and it will tell me the type. It will tell me all of the explicit arguments. And I can drill down and figure out what's going on interactively. And then all of this is generated in Lean and then just shown as a, it's just the VSCode extension is just given some HTML and some magic to get all the event handling to work. So we can see, oh no, I'll do that with a simple. Work of how this, of like the widgets, the code that actually makes this look good is in this file interactive expression.lean. And so in MathLib source/tactic/interactive expression. So check that out if you're interested in how all of this works. Okay, so I have some other.
Ed, I think we are losing you. Ed, can you hear us? We can't hear anything. At least I can't.
Yeah, me neither.
Oh, too bad.
We've lost Ed.
So he's no longer connected to Zoom. I guess we can
consider
wait
on twiddle our thumbs until he gets back. This is the downside of one of many downsides of these virtual events. Although the fact that we have 115 people in the room right now is one of the upsides of these virtual events.
It's true.
While we're waiting, there's a question from, oh wait, never mind.
Guys.
There's Ed.
Hello?
Hello.
Yes, you're back.
Sorry, my internet connection died. Okay, it should be fine now. Okay, I'll just continue then, yep.
Yeah.
Sorry about
that.
No problem.
So here I have an example made by Angela Lee quite recently, which I just thought I'd show to show you some of the interactive stuff working. So Angela made this cool HTML for a Tower of Hanoi. And as you can see, you can kind of click through it and it will show you the solution to the tower occurring. But the other cool thing is that you can actually interact with this. So you can lift up the tower block and move it around. And then it's actually saved the moves that I've made just then. And so I can click commit. And now it adds it to the editor here. So it will probably crash because they were bad moves. But the idea is that you can also interact with the editor using this system, and it's fully interactive. So I thought that was a cool example. Okay, so now I'm going to just quickly give a tutorial for how to make your own widgets. So this is what it looks like. So you can use this new command called #HTML to make your own widgets. So here we can see, again, we're making a div and it needs to be purple and say hello world. So now if I click here, I get the widget appearing here. And then another top tip is you can open your developer tools for the web view and then click there. And then just to confirm that it is actually generating that piece of HTML, and then I can add extra exclamation marks. And yeah, and then it updates in real time. So if we look at the type signature for this H, it takes a string, which is this tag, the HTML tag, and then a list of attributes, and then a list of children. So here the only child is a string, but we can make this more complicated. So in this example, I've got a list. Pin that. So that's, oh dear, I've got a comma. So here we can see, so here's some text. It's written it a few times, but don't worry about that. It's because I pinned it multiple times. So we have an unordered list, the list item, and with some text in it. But we can also add other types of HTML, so we can add LaTeX to it. Let me put the commas in the right place. So here we have a proof of some integral. And so this is using the KTech maths typesetting engine. So here you can see the source code. Similarly, we can have images. Yeah, the commas again. Some parrots. And then also we can have SVG as well. So maybe this could be used to make some graphs or something. So that's an SVG. I can do like purple. Now it's purple. So the idea is that you write HTML to look like this, but in order to make it interactive, we have to start fiddling around with these actions. So let me show you an example here. So here I've rendered a button and it says click me. And then the idea is if I click the button, it inserts something into the text. So So now let's explore how this works. So the idea is we use these things called components. So if you ever used Elm or React or a similar kind of functional UI library, this is a very similar thing. I think there's one in Haskell called Netwire, I think. And so the idea is we have this thing called component.pure. So let me hover over the type signature for this. So component.pure accepts this function which takes props, a type, to a list of HTML, and then this thing called an action, which we'll get onto in a sec. So the idea is that you can define a user interface as a function from the type you care about. So perhaps it's a mathematical function or an equation, or perhaps it's a graph, and then you just need to provide a function from that to some HTML which is the visual representation of that data. And so that's what this view thing's doing. And then the next part that's interesting is this action thing. And then so what this does is it allows you to interact, to create interactive HTML. So in this example, I have this button, and then I say on click, I want you to emit an action which returns this string. So if we look at the type signature of this component.pure, it's returning a component which takes a unit. So these are the props. So given a unit, make a user interface of some kind, and then the action type is string. So when the user interacts with this component, it will emit events containing strings. And then I have this kind of wrapper component here with effects, which causes Lean to tell VSCode that it needs to perform some kind of side effect. So for instance, this could be inserting text into the editor, or it could be copying something to the clipboard, or requesting that the editor navigates to a certain part of a file. So this is how you feed back and add things to the source code, the Lean source code. So here, for example, it converts our text. This is our string, so this will be I got clicked, and it emits this widget.effect.insert text. And so this is a way of telling the editor, please insert the given text at the cursor's position. And so finally, so if I click me, it does that because VS Code knows how to deal with these insert text events. And then finally, there's this ignore action thing, which just converts. You can see what it does. It just says, throw away all of the events. So after this event has been fired, it just gets ignored after that. So this kind of component system is used so that you can have statefulness, and you can have components in cause effects in the editors in certain ways. So you're no longer just having a static function from the thing you care about to some HTML. You can also cause that to interact and change what the widget's doing. So here's a more complicated example. So I'm bringing up this example to kind of explain the stateful, the stateful component. So what does that mean? It means that we have this component. Let me show you to start with. It has two buttons, a plus and a minus, and then this number in the middle. And the idea is this is a state. So as I click plus and minus, I can increase or decrease the value of the widget. So for instance, the statefulness is used back here to say whether or not this tooltip's open, for instance. That's a stateful transition. So that's kind of a practical application of states. But here's a very simple one where the state's just a number. So in order to implement this, we need to define a number of things. So the first thing we need to say is what the state is. So here the state is an integer. We need to say what are the ways in which we can change the state. And so this is what counter action does. So if we look up here, we have counteraction. You can either increment or decrement with a counteraction. Finally, next we need to say what the initial state of the counter is. So here it's just a 0. We need to say we can optionally provide a way for the state to change if the props change. But since our props are just unit here, we can ignore this one. And then the final thing, the next thing we need to add is this update function. So that takes an integer, our state, and an action. So remember, that's either increment or decrement. And then it produces a new state and optionally an action to forward to components that are further down in the tree, the UI tree. So here we can see if we have the state I and the action is increment, then add 1 to the state. And similarly, if it's decrement, take 1 off the state. And then finally, we have some code that says how to take a state, so this integer, and then produce the actual HTML that gets rendered from that. So here you can see we have a button with plus written on it. And then when this button is clicked, send an increment counteraction. We have the value of the state here. So it just says convert I to a string and then show it. And then another button with minus on it. And then you put those all together in this with state constructor.
What is the option alpha in the preceding function?
Where are we looking?
Maybe I missed that in counter update.
Oh, here, yes, sorry. So the idea of this option alpha is that you can have nested components. So for example, I could have it so that whenever, if I is 4, so I can like, I don't know, if I equals 4, then send this. And okay, so this won't compile, but the idea is here, in the case of I click decrement, and if I is 4, then you can optionally send an event to the parent component, which is hosting the counter. So for example, so yeah, an example is in here, these X buttons. When I click X here, it sends a message to the parent component through this option alpha system, saying close this tooltip.
Sorry to interrupt, but there's really a lot of noise right now, and yeah, it's really annoying. And this
Noise.
Yeah, there's a high-pitched whining coming from, and as far as I can tell, it's from
me.
Ed, but I'm not sure.
Oh no. I can't hear any whining.
Yeah, I mean, it sounds like
still going,
issue, perhaps, but
you just fixed it, maybe, Ed.
Is it
it's
fixed?
coming and going.
Oh dear, I'm sorry.
That's right. We'll survive. We can hear you.
We can survive. Yeah, so the idea is you can have nested components like here. So yeah, so if you click X, it will send a message to the parent component saying close that tooltip. Yeah, I'll just get rid of that. Right, and then so here we have this stateful component, and then you can also, and then the idea of having the state connected to this counter is that you can have multiple states, and they're all tracked properly. So even if I make several counters, it will track the states properly. And so, and this feature is what lets you have these nested tooltips here. So each one has their own state, even though they're nested. Yeah. Okay. So I think that's the end of the demo. So that was like 30 minutes. So let me head back to the slides. I think sorry, Jesse's texting me. Right, so that's kind of how widgets works. Hopefully that gives you a taste of how you'd make your own widgets. So the basic, I think like the basic thing I want to get across is that there are still some problems with it. So for instance, you can't really do concurrency with it. You can't have a long running operation, which I don't know, is running like simp on every single subterm or something. The UI will just freeze until that's completed. So I like the idea of adding some kind of task system to it. So Lean already has tasks, but there would be a bit of work needed to get the tasks to work with widgets. So I think there are still some problems with it, but the basic point I'm trying to make is that instead of having quite a wide API for Lean in terms of what is presented in the info view, instead it should just be a general UI framework so that users can come along and make their own UI for whatever they want. So for example, if they're working in category theory, they could try making like a commutative diagrams widget or something. That sounds quite hard, but that's just an example of something that you might be able to do. And then the idea is, because it's all in Lean and because it's all written using this UI system, you don't need to coordinate with making sure it works in VSCode and writing JavaScript, or now, oh no, maybe I need to get this to work in the web editor as well. So there are now multiple clients that you're targeting. And then if you just do it all in Lean with a UI framework, then you don't need any of that. You just need to implement this widget rendering system and then do everything else in Lean and get Lean to generate the UI for you. And I'm hoping that with Lean 4 has this really cool parser, which I think we might see a bit more of this afternoon. And so I'm also hoping to like add like HTML style syntax to Lean to the widget system as well. So you actually write, it's as if you're writing HTML within the Lean document, and then it's just showing the HTML instead of having this kind of weird HDiv language. Okay, yeah, so I think that's basically all I wanted to say. Thank you very much. I've got a few other slides with some technical details on if people are interested, but I think I'll leave it there. Thank you very much.
Thank you very much, Ed.
Yeah, sorry about the technical difficulties.
I think we got your talk anyway, so that's fine. I think we have a couple of questions. Maybe Macarius had a question.
Oh yes, hi Macarius.
Hello. So D3 in Matrix is quite impressive, but can you do plain old pretty printing of lambda terms according to Open 1982? I would like to see an HTML implementation of that. Of
lambda terms? Do you
just
mean like
normal? So you have a big lambda term and you want to have the blocks and breaks, and when you change your window, it should be reformatted and so on.
Oh, you mean like sorry, there's a bit of echo. I'll be more quiet. There's you mean like Waddler style pretty printing? Yeah. So actually, that was yeah. So Daniel Fabian actually found a CSS trick, which means you don't quite get exactly that, but you do get something similar. So here, it might just work here. That's a bad example. Let me find a better example. So if I go back to, I'm a bit worried I won't be able to find an example under pressure. So, so you can kind of see it here. So it's added some formatting space after where this equality is. And if I make it even thinner, yeah, see, and now it's added so it's not perfect, but yes, you can do this kind of formatting thing using some CSS trickery. Is the basic answer to the question. So the word wrapping is kind of intelligent in some way.
So do we have other questions?
Yeah, there are other. Is there a way I can see the chat?
Ed, you mentioned the web editor.
Mm-hmm.
So the widgets don't currently work in the web editor, right?
No, they don't. I have a fork with the widgets on,
cool.
which will eventually be done.
That sounds great.
But like it's done in theory, and in like there's a prototype of it.
So the examples you mentioned, the Rubik's Cube thing and the Tower of Hanoi, these were just developed on the Discord, right? It's the sort of
exactly. Yeah, these were like, it wasn't like
none of this serious stuff that's happening on the Zulip chat.
Like you don't need to faff around with, editing JavaScript and regexing stuff. You just, so I think we can see the code. So it's in here. So this is all the code that generates the Hanoi, the actual HTML. So I think Angela did it all with inline styles. So yeah, you write this HTML, and then your output is this, and it's animated. Okay, it broke there, but you get the idea.
It's still work in progress.
Do you want to tell us a bit more about what kind of interactions you expect? I mean, general purpose interactions, not the specific things like Sudoku or Hanoi.
So could you say that again, Patrick? Sorry.
So could you tell us a bit about what kind of general purpose interactions you would like to implement?
Yeah. So like the main dream, which I'm working on at the moment, but I don't quite have it done in time for this talk, is, so for instance here I can click on this, right? So I have a full structured pretty printing system here, which is aware of the expressions and how the expression boundaries lie. And I'm really, really keen to have it so that in this box you get it tells you the available rewrites at that position in the expression, because that's maybe like, when I'm actually proving stuff in Lean, that's maybe like 40% of what I do is try and remember what like the composition app homomorphism's called. And I really like, just you click on that, it tells you here are all the rewrites that are available for this specific sub expression, and then you just click on it and it adds it in, and then you can get on with your life proving stuff. So I think that's like my main dream at the moment. But yeah, I didn't quite get it ready in time for this.
Okay, thanks. In the meantime, we got another question in the chat about freezing the updates and the iron curtain style.
So there is this, I'm not sure if this is quite what you mean, but you can pause. So now it says paused, and now hopefully if I navigate around, it freezes it, right? And even if I start editing stuff, it just keeps it. I don't think the widgets are paused as well though, so it's not perfect. But I don't know if that's what you mean in the chat.
Right. So I'm aware of the pause feature, but I like that to be kind of like the default, so that like we do not need to like keep toggling it every time. But
keep watching it every time?
Toggling it every time.
Oh, I see. So like if I go somewhere else. Yeah, I think that should be. I think if you make an issue on VSCode for it, like I'm sure we can sort it out, because yeah, I don't. There's still some stuff to do with this info view and getting the pausing and the pinning right, I think.
I think another design for it could be.
Everybody, you want to be able to offer the opportunity of doing that, but clearly most people are very happy with the interactivity of the experience. Maybe we'll keep more questions for the coffee break. We have a coffee break now, so we can grab some drink and go to Wonder if you want to discuss things. or type messages on Sleep. And I will resume at, well, in my time, it's Central European time at 5:30, so it means half an hour away from now.
Yes, back in 30 minutes. Thank you again, Ed. That's like super impressive stuff.
Cheers.